Hi, I am Bhavik Thakkar. Welcome to the fifth part of our percentage series. If you're more comfortable with Hindi language, you can hit the I button which will take you to the Hindi version of the same video. And if you're more comfortable with English, just carry on. Well, in the first video of percentage, we understood how exactly can we calculate two basic calculations related to percentage. We also understood how exactly can we answer those what percentage questions using the definition of percentage. Well, in the second video, we understood how quickly can we calculate the percentage related calculations using Beatitude approximation technique. And the beautiful part of Beatitude approximation technique is, in case the options are closer, we can get to the precise number for this kind of calculations with the investment of another 10 seconds. Well, in the next video, we understood that all the percentage are related to a particular variable. So whenever we are supposed to find out percentage, we have to understand that they are related to these variables implicitly. So if nothing otherwise is given, we will use this particular base to calculate those percentages. Well, next thing we understood the beautiful part, those two beautiful methods for which we don't have to mug up anything and without any formula will be faster than our competitors using these two methods. Now today is the time to actually use those methods in real exam questions. We have already done one video in which we solved some of the questions, but in this video we are going further up and we are going to solve some more questions so that all different kind of varieties are covered and we feel much more confident. So let's get started. So let's cover type of the questions which haven't been covered in the previous one. Well, one very important type of question which examiners ask in percentage is this, where the three variables share this kind of the relationship where two variables product is the third variable. For example, speed into time is distance, or you can say price into quantity is expenses, or you can say length into width is area. So many a times what these people do is the examiner will give us the percentage changes in two of these three variables and we are supposed to find out the percentage change in the third variable. This is a very favorite area for percentage questions. Alright, let us see how we can answer these questions. Well, as you know, now I am not going to solve each and every question using both the methods. I would give you an idea which method would rather be easier to use here. Fine. So in I would say we'll have to compare multiplying factor method with replica method. Which one would be easier here? Look, whenever this kind of the relationship is there, it's very easy to use multiplying factor method. What we'll do is we'll assume all the numbers to be 1. So previously, before the changes, 1 into 1 is equal to 1, right? We'll assume all the numbers were 1. So here the thing is that price is there, number of articles and sales. We all know price into quantity is equal to sales, right? So we'll assume that before this changes, all were 1. So 1 rupee was the price, 1 article we were selling, so all we were getting was 1 rupee, right? That was the sales. Now what has happened? The price is increased by, we all know, what is this? 3 by 8. So if price increases by 3 by 8, now we know the new price is 11 by 8. Then the quantity is decreased by 2 by 11. So if the quantity has decreased by 2 by 11, it has actually become 9 by 11. So quantity is actually 9 by 11. And now we can understand what will be the sales. 11 will get cancelled. Your answer will be 9 by 8. Now the question is, what is the effect on sales? So it was 1 before, now it is 9 by 8. How much is it increased? 1 by 8, and that is nothing but 12.5%, right? 12.5%. As simple as this. So obviously this is much easier, right? And you actually don't have to even write this particular statement because I am explaining for the first time. I wrote it. You directly say, okay, price has becomes 11 by 8. The quantity has become 9 by 11. So sales will be 9 by 8. 9 by 8 means 1 by 8 more, that is 12.5%. Within 10 seconds, that is all you require to answer this kind of a question using our method without memorizing any formula. Are you getting this? Alright then, let's move on to the second question. Again, what does it say? Price increased by this much and budget has also been increased by this much. Then our consumption should have been reduced, quantity, right? So we'll understand all of them. I'm not even supposed to write this like my budget, but I'm just, because I'm explaining, I'm writing this. Initially all were one. One was the price, 1 kilo we were consuming, one was our budget. But now the price is increased by 2/3. That means it is now 5 by 3. Quantity we don't know, right? That is what we are supposed to find out, consumption. But budget, we have already increased it by, what is this, 6 by 6, 2 by 3 is 1 by 15, right? So 1 by 15, that means budget is 16 by 15. When you increase something by 1 by 15, it is 16 by 15. What will be the quantity? X, 5 by 3, so you know that it is very easy, right? It will go that side, 3 by 5, and it would be 16 by 25. So that means your new quantity is 16 by 25. Initial was always 1. So what is, it is reduced. It is reduced by 9 by 25. In percentage, just multiply it by 100 and you will get 36%. So wasn't it pretty simple? So our technique, are you getting this? Just use multiplying factor method most of the times for this kind of the numbers. Unless the numbers are very weird, then you know we'll have to do approximation. We already done that kind of a question in our last video. Alright then, simple enough, we can understand this. Very good. Let's move on to the next one. Here it is rectangular part. So we know we are talking about the same area. So the question goes something like this, that I wanted to buy a rectangular plot of a particular square meter. I saw a plot of exactly same area with the width is given and it is given the length was 40% more than my requirement. Alright. So now we are comparing two different rectangles, one which I wanted and one which I saw, right? And area was same, but wanted and what I saw, the area was same. So I can say length into width was same in both of them. So I can actually say the length in which I saw was, sorry, width was 210 and length was 40% more than my requirement. So if my requirement was, I would say 100x, this is 140x, right? And here the width of the plot I want, that is what we are supposed to find out. Say k, that is what I am supposed to find out. X will get cancelled obviously, 0, 0 will also get cancelled, 5 and 7, right? That's about it. This 5 will go here, 42. 42 into 7 will be 294. That's about it, right? That will be your answer. So the question looked difficult, but if you understand this normal relationship, and there was even a better way to answer this. If you understand one thing, look, basically, as I told you, A into B is equal to C, right? Like here, length into width is equal to area. And if the area is same, you can understand that these two are inversely related. For example, if the length is double, the width has to be half. For example, 4 into 2 is 8, right? So if this length is double, 8, then this width has to be half. Then only 8 into 1 is, again it will be 8. They are inversely related, right? If 4 becomes 8, double, then this will have to be halved. Are you getting this? This is simple. So here also, if you understand in that manner, you don't even need this. You can directly understand that if my length was 40% more, 40% means 2/5 more, right? 2/5 more, that means instead of 5, it is 7. So if length is instead of 5, it is 7, then width is instead of 7, it is 5 in that ratio. And this 5 is already given, and now we can compare. This is just our replica. Now we can actually compare. So this is what I wanted, this is what I saw, and what I saw was 210 feet. If 5 was 210, 7 was how much? 5 into 42, 42 into 7, again the same answer. Getting this? So it depends. If you have got this kind of a logic, you can also understand that. So the relationship is pretty clear now. Let us try to understand. Whenever A into B is equal to C, A and B share inverse relationship. Their ratio have to be exactly inverse. If A goes from 7 to 8, then B has to go from 8 to 7. Then and then only 7 into 8 and 8 into 7 will remain same, right? So if that constant is same, then they are exactly into inverse ratio. So one's ratio is 5 to 7, other ratio will be 7 to 5. The ratio we know, and once we know the ratio, we can say 5 is 210, 7 is how much? Fine. So you could have done it in that way as well. Alright, then let's move on to the next type of question. Percentage changes on various variables. Not this, that A into B is equal to C. If that are the kind of relationship that variables are sharing, then we know multiplying factors is easy. But in any other relationship, usually visualization is the key. So you make a replica so that you can visualize the things. For example, like this. A spends this much percentage of his income. His income is increased by this much percent. And he increased his expenditure by this much percent. Now, by what percentage his savings have increased by, right? So we all know income minus expense is equal to savings, right? We can use this. We can actually think A spends, what is this? 7 by 8, right? 7 by 8 of his income. So if his income was 8, he was spending 7, he was saving 1. We can take an example, replica. Next, his income is increased by 2 by 9, right? This is nothing but 2 by 9. Now look, that's the key. Here, look, you can either go with the multiplying kind of factor as well, but I would say because his income was, we assumed it to be 8, now 2/9 of 8 will be decimal or fraction. And if you don't want to deal with the fraction, what you can do is, you can take another replica. Say, because this is not divisible by 9, what if I multiply it by 9? Let me multiply all the numbers with 9 to make it easy. Are you getting this? I would say 8 into 9, his income was 72. 7 into 9, 63. He was saving 9, right? The same replica, it doesn't make any difference because I multiplied everything with 9. The replica still maintains that he spends 7/8 of his income. 7/8 of this he is spending. Getting this? So it is still the same. Now, his income increased by 2 by 9. So I can say, okay, now I know, right? 16. 2 by 9 of this will be 16. So his new income will be 88. And he increased his expenditure by 1 by 7, right? He increased his expenditure, increased by 1 by 7. So his expenditure was 63. 1 by 7 of this is 9. He increased it by 9. So now he is spending 72. And now he is saving 16, right? So his saving increased by what percent? He was saving 9 before, now he is saving 16. 7 by 9, right? So that is, now we can understand, right? 7 by 9 is 77, 7 by 9%. 77, 7 by 9%. That's your answer. Are you getting this? Just make a replica and you can visualize everything. You can visualize. So first of all, I said, let me make 8 and 7. But then I realized because he is spending, that is okay, 1 by 8, sorry, he's 7 by 8. So he is saving 1 by 8, which is okay. But then I saw that his income is increased by 2 by 9. So if his income was a multiple of 9, it would have been easier for us. So I took that kind of an example. I just multiplied everything with 9. So this is my new replica, and then I said, okay, he was earning 72, he was spending 63, he was saving 9. Then his income has increased by 2 by 9. So 2 by 9 of this is 16. So it has increased by 16, it has become 88. He increased his expenditure by 1 by 7. So his expense was 63, 1 by 7 of that. Are you getting this? 9. So his new expenditure is 72. So his new saving is 16. So his saving is increased from 9 to 16. That means it is increased by 7 by 9. In percentage, it is 77, 7 by 9%. Are you getting this? Pretty easy, right? This is how you should be able to do this. Let us go for the next question. All right. In a public school, 20% of the girls and 1/3% of the boys are under 12 years of age. If the number of girls, now look, that is okay, but how much are girls and how much are boys, that is first important. So we can not start with this particular statement. Girls and boys, we are given the data, but how much of the total are boys and girls, that we can get from here. The number of girls is lesser than boys by 20% of the total strength. Now this is something that I already explained you. in that, I think, second video, right, where I've explained you what exactly we can, how can we interpret this kind of the sentences. This means total strength is always 100% and girls are 20% lesser than the boys. So what did I say? 100 plus 20, 120 is half, 60 is the higher number. Do you remember? Right? When total is given, again I am telling you, when I would say boys plus girls, right? Boys plus girls are always 100% because it is given in percentage. So total strength is 100%. But girls are lesser than boys by 20%. So boys minus girls are 20%. So here we can say B plus D, B minus D. If you add those two equations, 2B is equal to 120. So B is equal to 60. But I have already told you, like, whenever total and difference is given, the greater number is sum divided by 2. We remembered that. If you memorize that, we don't have to make the equations and solve it. We can directly say 20, total strength is 100, 120 is half is 60. So boys are 60%, girls are 40%. And now we can actually use this, that 20% of the girls, so 20% of this is 8, and 1/3 of the boys, 1/3 of these will be 20, are under 12 years of age. So these all together 28 students are under 12, and we have been asked what fraction of the students are 12 years or more. So if 28 are under 12, total is obviously 100. What percentage? 72% of the students are 12 years or more years old, right? Pretty easy, right? It's all about understanding that particular statement. If you interpret that statement correctly, it becomes very simple. So what we do, we make a replica, right? All right, then next one. In a city, 35% of the population is of migrants, 20% of those are from rural areas. Of the local population, this much, so many things are given, right? So many variables. What we do, we just make a replica. Let's assume, because maybe here 100 is the total population. In a city, 100 is the total population. 35% is composed of migrants. So say some people are migrants, others will be locals, right? So migrants are 35, locals are 65, obviously total is 100. Then we say are migrants, out of whom 20% are from rural areas. So migrants are also from two different kinds of areas. Either they are coming from rural areas or they are coming from other urban areas. So we can say, all right, I would say let's take another page. This would be too small for us. So let's take another page here. Say 100 is the total population, migrants and locals 35 and 65. And we were told that 20% of migrants are from rural areas. So that means out of migrants, some of them are from rural areas, some of them are from urban areas. 20% is 1/5. So 7 and other 28 are from urban areas, right? So we can just take a replica. We are just taking a normal replica. Now what they say, of the local population, 48% is female. Okay. While this figure for rural and urban migrants is 30% and 40%. So now out of these, how many are females is given as well, right? Okay, 48% out of the local population. So out of this local population, 48%. Look, this is not a round figure, right? So it will become a bit difficult to find out 48%. So what if we put 10 everywhere, so that everything is round figures? It's the same thing, right? In replica, if everything is multiplied by 10, it is still the proportionally same figure. So now we can make 48% is nothing but 50% minus 2%. Now it is easy. 325 minus 2% will be 6.5 is double, 13. So we can say 312. So 312, so these are females. Are you getting this? Out of local, these are the females. And what they say? They said in the migrants, rural and urban, 30% and 40% are women, are female. 30% and 40%. So 30% of this will be 21, 40% will be 28 into 4, 112, right? So these are females here, these are females here, and these are females there, right? Now what is the question? The question is, what percentage of population is female? What percentage of population is female? So females are this plus this plus this. that makes it 133 445, right? Out of 1000, what percentage is it? 44.5%, right? In 200, two zeros will be cancelled and your answer will be 44.5% is female. Fine. So it's very easy when you make a replica in this kind of the question, because there were so many different variables. If you have to go in one variable, like 1/3 of this, 2/3 of that, 1/3 of again, then we make it with multiplying factor method. But this is the question where there were so many different things. So we'll take different variables, we'll put some replica, we'll assume it as 100 or 1000 or something like that, right? Makes it very easy. Alright then, next question. The population of the upper part is half the lower part of a town. Upper part has fallen by 1/6. Okay. And the latter has risen by 1/3. Okay. And total number becomes this. Then what was the total population at first? Alright, look, how would you think about this? First of all, try to understand this, that multiple of 3 and 6 is very important, so that we can easily find out 1/6 and 1/3 of those numbers. So what will be the LCM of 3 and 6? 6, right? Now as we are given that upper part is half, so let us say if upper part was 6, then lower part was 12. Just take some example. We have to take the multiple of 6 anyway, because 3 and 6, the multiple is 6. So we'll say, let us keep 6, let us take both of them as multiple of 6, but upper part is half. So upper part is 6, lower part is 12, right? Now this has fallen by 1/6. So that means 1 decrease on 6. So now it has become 5, right? And there it has risen by 1/3. There is 1 increase on 3. So 1/3, that means 1/3 of 12 is 4. Now it is 16, right? So this is a replica. Now we will compare apples to apples, orange to orange. Now we know. So in my replica, total is 21, which is given. Now the total number of inhabitants become 21 is given as this 25,200, and we are supposed to find out total population before. Total population before was obviously 12 plus 6, 18. Fair enough, right? 12 plus 6 was 18. So we are supposed to go from 21 to 18. Now we know if 21 to 25200, 18 is how much? You can cross multiply, or if you have got that I will think like this. This is 7 to 6, 1/7 come. So I will divide this by 7. 7 3s are 21, 42, 7 6 are 3600 come. So 3600 lesser. So that means 4000 lesser will be 21,600, right? So the answer would be 21,600. Good enough. So it would become, now it all depends upon you how you deduct. How I deducted was, I subtracted 4000 and then increased 400. So 21,200 plus 400, 21,600, right? Instead of going with the traditional subtraction, I do it something like this. So I hope this is pretty easy. You are getting the thing that whenever there are various variables, we will take a replica and it becomes pretty easy. Alright then, what about this particular question? If 16 liters of water is evaporated from 56 liters of sugar solution containing 17% sugar, find the percentage of sugar in the remaining solution. Well, this is very interesting question. Look, one way of doing it is, obviously, now look, what you can understand is, when water is evaporated, the sugar will still remain the same. The quantity of sugar, right? Absolute quantity of sugar will be the same. Fair enough? There is a solution. So if water is evaporated, but sugar will remain the same, right? So sugar, initially it was 56 liters and sugar was 17%. So 17% of 56 liters, right? That is now how much percentage of 40 liters? What else? Right? Because now it is 56 minus 16 is evaporated. So now the total mixture is, total solution is 40 liters. So the sugar is same. It is equal. It was whatever it was before, it is also now. Because sugar cannot be evaporated, only water can be evaporated. So sugar is still the same in both solutions before and after. So we can actually understand that 17% of 56 is what percentage of 40, right? So it's nothing but 40 will go here. It's pretty easy, right? 10 fours and 14 fours. 17 into 14 is very easy. 170 plus 68. 170 plus 68 will be 238. Divided by 10 is 23.8%, right? Pretty easy. This is how you should be able to understand this. Fine. There are various ways to do it, but the best way is to think like this. This is what you are supposed to understand, and this is what you are supposed to learn, and this is what you are supposed to do in your real exam, right? Very easy again. Whenever you evaporate water, the other part remains there the same. The quantity will not change, right? So in the beginning it was 56 liters. In the beginning there were 17% sugar. So how much sugar was this? 17% of 56. Fine. And that is what percentage of, now that is what they are asking. What percentage sugar in there in the remaining solution after this 16 liters is evaporated. So now remaining means 40 liters. So that is what percentage of 40. As simple as that. Fine. Alright then, I hope you enjoyed it, and this is how you should learn, and this is how you should be doing your percentage questions. If you want to learn more about it, and if you are pursuing any of these courses, we have got Bititude online packages for the same. If you want to know about them, you can hit the I button and get the information. And if you still have any other queries, you can actually call on this number to get all the information. Alright then, and you can of course watch all the videos that we are frequently uploading in our Bititude channel. So please subscribe to our channel and hit the notification bell. That is the most important part, because even if you subscribe to our channel, you will never know about our new videos unless you have hit that bell icon. Because if you hit that bell icon, as soon as I upload a new video, you will get a notification and you can watch all those new videos. So keep watching, keep learning, and keep enjoying.